record. All right, Ismail, the floor is yours. Good luck.
Thank you, Jawad bhai. Assalamu alaikum, everyone. I am Ismail Hussain, trainee software engineer at Cepalo. Today, I will be giving a deeper look inside a fundamental challenge in current AI world, that is measuring LLM's capabilities. Throughout the session, I will be talking about benchmarking and why benchmarking is needed, and we'll also be conducting a live benchmarking demo, and I will be sharing a research example of mine, and we will also be talking about evaluation versus benchmarking. To begin with, let us first start with a story. Let us all imagine that Cepalo made a very bold decision of making an LLM, and after so much hard work, they released it and named it Cepalo 1, which has a good context window capacity as well as excellent throughput. And after making it, Cepalo claims that Cepalo 1 is the best LLM ever made. Seeing Cepalo, X company also decided that they are capable of making LLM, and after hard work, they launched it and named it X1. This LLM has good memory efficiency and good reasoning capabilities. And like X also claims that X1 is the best LLM ever made. And after seeing Cepalo and X, Y also decided that they are making an LLM, and they named it Y1, which has good scalability and good inference costing. And like before, Y also claims that Y1 is the best LLM ever made. Now suppose our end users, Mehdi, who is a student preparing for his entrance exam, and OP, who is a chef, seeking a large language model that has good action reasoning. But for them, both of them want the best LLM in the market. But both for Cepalo and X1 and also Y1, they claim that they are the best in the market. So both Mehdi and OP are in a dilemma that which LLM they should really choose. And finding no other way, Mehdi decided that he will be testing each LLM one by himself. So he starts asking his academic related question to each LLM and checks if it gets all the answers correct. And like Mehdi, OP also decided that he will be testing each of the large language model by himself by asking questions related to cooking and test if the model gets the answer correct. And this manual process, if you have noticed, is very unscalable. Like others, if anyone else want to do this same process, have to go through a long process. Like if someone want to test 1,000 or 2,000 questions, then he have to write all the questions manually and checks if the LLM gets the answer correct, which is very time consuming. And also the context in which the OP or Mehdi is chatting get contaminated by the context he is chatting with, and also the order of the questions might affect the response of the next question, and which might also pose some biasness. And there is a better approach that we can take instead of this manual approach, which is using dataset. Dataset can enable us to have the state of the context in a very clean way, and for both for Mehdi and OP don't have to bear the pain of writing each questions manually. Now I will be showing you an example of manually evaluating LLM, but before that, let us see a leaderboard of large language model. This is a leaderboard on Hugging Face, where different open source models are compared on different kind of data set, like math question, where they are asked math related question, and GPQA, like PhD level questions which are not solved, and also MMLU, that is Massive Multitask Language Understanding. And these are the models behind in the leaderboard. And for our benchmarking process in manual way, we will be using this model. This is Bangla pretend model, that is modification version of Llama 3. And this model was pretend on Bangla dataset. And the dataset we will be testing with, this is the dataset. This is a massive multitask language understanding question in Bengali, where there is a question and there are options. There are 4 options here. There is a answer. We will be passing the question and the options to the model, and the model have to choose a option among them, and we will check if the model response aligns with the correct answer here. And for the coding part, I will be visiting this site here. For you to test this along with me, I'm sharing you the link of the collab with you. You can find the collab notebook link in the chat that I have shared. And firstly, we need some libraries to install, and we need to install the model here. This model. This is the same model. We download in the collab environment, and we give it a simple prompt, which give it a response like this. And after that, we download the dataset from Hugging Face. This dataset here, which contains about 6,000 rows or samples. And after downloading the model, we format a prompt. Designing a prompt is very important, and the correct way we are designing the prompt is like this. This is the template where there is a question, and the options here. Options are mapped with options like A, B, C, D, and this block here, coding block, maps this question with options of A, B, C, and D, and then the model is asked to choose an options. And for this case, we ask the model to give a response in one token for A, B, C, or D. And if the model gives the response and it aligns with the correct answer in the dataset, we count the score and increase it by 1. And if we run this cell, for time convenience, I have only choose 20 question from this 6,000 samples, and where each of the question are passed one by one, and the model guesses, this is the model guess, and this is the actual answer. And there are 20 questions like this here. And after the whole process, the output looks like this, where we passed 20 questions and it gets only 4 correct from all the 20 questions. And the accuracy is about 20% here. And this was the manual process of testing the large language model against dataset. And if you have noticed, there is a duplicate effort. Like if you want to test the model now, you have to do the same process of downloading the dataset, then downloading the model, and also format a prompt like I have done. So which is a very duplicated effort. So there is a better way to avoid this duplicated effort, where you can use benchmarking framework. So it can relieve us from the pain of writing the same code again and again. So what frameworks really provide? Among the there are a couple of things, and I have highlighted only few of them here. Like data handling, the framework downloads the data set in its environment without having us to download the dataset by ourselves by writing Python script, and also the execution, right? Like passing the prompt to the model, and also push processing of the answer, like extracting some special parts, and also very important thing, the metrics, like you can use accuracy with mean, or like F1 score or BERT score, this kind of matrices. And through framework, someone who is testing a large language model in Dhaka can get a same score someone testing in the area of San Francisco. So this is a workflow diagram of the framework, which executes in four phases. In the first phase, the raw dataset gets downloaded, and it gets passed to the formatted prompt. And there are two options, few short options and zero shot option. In few shot testing, the model first passed some examples, then asked a question to give answer from the ones in the example, like this. And in the zero shot prompting, the model does not have any examples prior to the testing, just it gets the question and asks to give a response. After that, there is execution engine, where there is a request manager that passes the formatted prompt and wraps for the model to choose from. And here we can use model which are open source, like models from Hugging Face or BLLM or other sources, and also closed source model through API. And after the processing of output, here which checks the logic for testing and parses the output, then we apply the accuracy matrices like mean score or F1 score, etc. And one of the widely adopted industry-wise known framework is LLM evaluation harness, and it can help us to avoid the pain of writing the manual process. And here I have prepared a notebook, for example, and I am also sharing this notebook with you. If you want to test along with me, I am sharing it in the chat. You can find the link of the notebook in the chat now. First, I downloaded, install the packages, required packages, then the model here. This is the model location we showed previously, and it is the same data set we have shown in the Hugging Face. And for time convenience, I have only chosen 10 samples from the data set. And the 10 samples are close machine. Okay, from this, the first 10 samples will be collected and passed to this model. And after this, we have directed it a path where it will download a JSON file. It will contain a report for the whole benchmarking process for this data set. Currently, the model is getting downloaded in the notebook environment. Meanwhile, you can also run the cell through the link I have passed in the chat. We have to wait a couple of seconds while the model gets downloaded. This model is about 3 billion parameters. But in real world scenario where each model like GPT, who is GPT-5, which is about 1 trillion parameters, which is very big, and Colab environment like this will not suffice to load this kind of huge model. And this is why we have chosen a small model that fits into the Colab environment of 8 GB 3 GPU. And the download is almost on its way, and now it will pass the questions one by one to the model, and we will see output here. Almost done. And this is a brief report of the whole process, and the process is done. The accuracy is about 40%, and this is the report in JSON file. If we open this report, we can see a holistic view of the whole process, like the dataset we have chosen and the accuracy it got, and also other matrices. If you run the cell, you will get JSON like this, and view each of the field, and we can also see how much time it took, and here there is the model name. And other matrices, for other matrices, you have to just go through the each field and understand what each field means. And like this, you can also choose Quen or any other model that in Hugging Face or through API, and other data set instead of this Bangla MMLU, and limit or other name you can choose. And there are other parameters which you can pass here. You have to just Google the framework documentation part. And back to our slides. And I wanted to check how LLM performs in Bangla language, where I chose 3 different models like Quen, Llama, and GPT-OSS, and I have chosen their quantized version. If you do not know what is quantization or quantized version, it is like same model, exact same model with a bit cut of its weights so that it consumes less GPU. This whole model may require a GPU that is not covered by end users PC, and quantized version requires less GPU compared to the full precision model. And for example, if I show you how much a GPU reduction gets after quantization, suppose a model has 65 billion parameter, and for the full precision, we need about this much of GPU memory or VRAM to download the full precision model. But if we choose quantized version, that is int 8 or 6 or 5, 4, etc. For int 8, we need a very less GPU compared to the full precision model. And that is why mostly the quantization is done to get the VRAM requirement fit into the model. And after quantization, the model's performance also gets dropped. I wanted to check how much drop each model gets after the quantization process for our Bangla language. And I'm sharing you some statistics that I have found. And these are the data set for Quen full precision version and the quantized version. In the data set, I have chosen 5 data set. You have seen previously the Bangla MMLU, that is massive multitask language understanding in Bangla. and also open web question and some other data set which you can find in Hugging Face. Across all these data sets, both the full precision model and the quantized version of the Cohen performance remains consistent. And also for Llama as well, across 5 data sets, its performance remains almost consistent. But for GPT-OSS, its performance is a bit low compared to other model, where the full precision version its performance is like this. But in quantized version for Bangla language task, the performance gets dropped, a huge drop actually. And it is the holistic view where there is a comparison of performance of full precision models, and we can see in Boolean question where there is a yes no option for a question, the Llama Cohen performance is almost very good compared to the GPT-OSS, which has 20 billion parameters. GPT-OSS performance is very low compared to other comparing with other 2 models. And for the quantized version, and here also the GPT-OSS performance across these 5 dataset are very low compared to the Llama and quantized version, which I have found out through conducting the research. And in statistical view of the previous slide, here you can see GPT-OSS as performance in quantized version gets a huge drop in common sense or open book related question. But for Llama and Cohen, the drop is not that significant, and sometimes the performance get increased by little. And previously have shown we only chose Bangla MMLU, but you can choose a wide range of task or data set, and which you can find in this documentation, like this one exact match here in the notebook, Bangla MMLU. This is the same task we perform, or other task you can find here in a wide range of languages, and also in wide range of topics like physical question or math related question. You just have to go through this documentation here. And for the output metrics we got, there are a couple of things we need to focus on, like the task or dataset, which we used Bangla MMLU, or you can pass any other question or task name here. And we have to choose the model correctly. And for the model source, we can find the name in Hugging Face, or if we are using API, then we have to adjust the command likewise. After that, the score of the accuracy and the number of samples we pass to the model. And the 2 options we get, few shot prompting and zero shot prompting. For our case, we used zero shot prompting. And here is the very important part, the accuracy matrix through which we will evaluate the score. And for our case, where there was multiple choice question, which the model outputs a strict response like A, B, or C, D. For this kind of data set, we can use a very strict way of measuring score, that is mean, and the evaluation time, the time it took for the whole benchmarking process. And the framework I have shown you, it supports a couple of matrices. Each matrix used for different or distinct data set. For probabilistic type of data set, where there is no options like you have seen before, A, B, C, or D. There we can use these matrices like perplexity score. But for classification type data set, we can use these matrices here, like standard accuracy or length normalized accuracy. But for translation or generative type data set, we can use BlueScore or character F score. Most used matrices are shown here, like accuracy, where there is a strict response the model gives, and we just check if the response aligns with the correct answer. But for F1 score, it is mostly done in medical or classification type dataset. And another is BERTScore that checks if the meaning aligns, the LLM's response meaning aligns with the actual response meaning, actual answers meaning. And I have given two sentences here where there is an actual answer, and LLM gives response like this. As human, we can tell that this both of the sentences are almost similar. But what about the matrices we use? Can matrices like F1 score, which use true positive or false positive value, can really find these two sentences are similar. For the word you, we can find that there is no word here in you in this sentence. And and in the F1 score process, this response we cannot compare. So here we can use BERTScore, which checks the similarity of both of the sentences. And I have implemented a code here. This is the same code here you can find. First, we install Python package BERTScore. Then we pass both of the sentences here, the actual answer and the LLM response we got from the LLM. Then we pass both of the sentences in the library function. And for the model, we choose a small size BERT model. And if we run this cell, we will get a precision score and also F1 score. The execution is almost done. First, the model gets downloaded, which is about 250 MB. And after that, we get the scores, F1 score, precision and recall score. Now, back to our slides. I have talked about F1 score previously, which is different from the F1 score we have shown right now. The F1 score from the BERTScore model. For the standard F1 score, we get a very hard count of the true false truthy value or falsy value, that is true positive or false positive values. But for BERTScore F1 score, we get true positive or false positive values like this in fraction value instead of this hard integer value. And for the standard F1 score, the process is like checking the exact word is there. But for the BERTScore F1, we check if the meaning are closely related instead of the standard F1 score process where we check hard similarity. And which metrics should we use in different cases? And for cases like multiple choice question in the task I've shown you, Bangla MMLU or Boolean question, where there are options and there is a exact match response, we can use metrics like accuracy. But for short answer extraction, like this data set, we can use F1 score. The data set I'm talking about, here is an example where there is a context and a question, and the correct answer here, this part is is in the context, and the model have to choose this response from this context. And this response we can find in about 270 characters in this context. And for this kind of data set, we have to use F1 score. And for classification type questions, we can use both accuracy and F1 score. And the dataset example is like this. It is the Bangla dataset, like where we are finding sentiment, and it is a category type dataset. For this kind of test, we can use both accuracy or F1 score. But for a task like summarization, we have to use the similarity or semantic meaning, and where we can use BERTScore. And for the dataset example, you can see this example where there is a big content, and there is a small summary of the content. For this kind of task, where we check semantic meaning, we use metrics like BERTScore. And now, why industry relies on benchmarking? The benchmarking is mostly done by researchers so that they can find bottleneck of a large language model and approach a solution for the model, and tech leads and CTOs so that they can find the correct LLM for their company or employee. You must have heard the contract between Apple AI and Gemini, Google, where Apple AI adopts Gemini. There they must have done a kind of evaluation so that the model performs well in their task. And also for product managers and regulators, they need to do benchmarking to choose the right model. Now consider a self-driving car or a medical scenario where you cannot just hope that LLM give a correct response. We really have to ensure that this model works well for our tasks. And it is very important to understand the difference between evaluation and benchmarking. Benchmarking is a subset of the evaluation. Evaluation is the holistic thing that we see nowadays in a different kind of leaderboard. It is mostly in LLM evaluation rather than a static subset of evaluation process, which is benchmarking. And the other tasks that are performed are human evaluation, where a human evaluates if the model response is correct and gives score. And also there is another subset that is one LLM judges the performance of another LLM and by doing reg or other kind of functions. And for the evaluation, we check if the model is really good for our task we are doing. But for benchmarking, it is like a statistical score comparison between different two models that I have shown you previously, like Ko and Llama, where I'm comparing their performance. And for evaluation matrices, we take a range of matrices to give score, like accuracy or cost of the model, and human rating or performance latency. But for benchmarking, the matrices are limited to a couple of matrices, like accuracy score or F1 score. And that was all for today. Thank you. Hope you have learned something new today. And if you have questions, please don't hesitate to ask.
Right, guys, if anybody has any questions, I think now's a good time to ask.
Yes, Zaud bhai, I have a question to Ismail.
Please.
Hello, Ismail. So thank you so much for your nice presentation. It was really eye-catching. I liked it. So my question here is that how do we can actually measure, like, if a specific question doesn't have any right or wrong answer? So overall, I understood you mentioned about evaluation and benchmarking. So actually, from the evaluation's point of view, how we can actually measure uh, if a question doesn't have a right or wrong answer?
Uh, uh, to get the question correctly, if you give a scenario like where there is a question but there is not any right or wrong answer.
Yes.
I'm asking you if you can give an example.
Okay. Okay. For example, if a model, I want to use a model for testing, and a customer is actually writing down prompts for getting some testing related responses, whether this product is good or bad. Yeah.
In this kind
Okay,
of
Shetu,
yes.
Shetu, if I may answer your question. So if your expectation is, I mean, if there is not a right or wrong answer, but the explanation, like what is the capital of Bangladesh, the right answer is
Mhm.
Dhaka. But if you
Yeah.
ask something which is more contextual and explanation, then you are not looking for accuracy. You are probably looking for BERTScore. So your answer, if it is
Okay.
the contextually in the right sense.
I see. Okay, bhai. Thank you.
Right. I think there's another question in the chat box from Mohibul Hassan. Ismail, if you could take a look at it.
Let me check.
Yeah.
Please give a takeaway and take first. One question: why not use future prompting to give more accuracy? For future prompting, it depends on the dataset. If the dataset provides such facilities, which I have shown you in the dataset of Bangla MMLU, each of the questions are distinct and independent. And if they prepare the dataset like this, we can definitely use future prompting. Hope you get the answer.
Right. So unless there are any further questions, I think we can end it today. Thank you very much everybody for joining. Have a great rest of the day. I will make the recording available by the end of today, along with the presentation slides. All right. Take care. Bye bye.
Thank you.
Thank you. Bye.